Hi, everyone. Good morning, good afternoon, or good evening, depending on where you are viewing this from. My name is Martin Yip, and together with my colleague Hisham Murad, we'll be discussing with you today how to virtualize any application and also efficiently manage your infrastructure with intelligent operations. Okay, so this is the agenda. So I will start off with a market perspective. Then I'll talk about how VMware enables you to virtualize any application with confidence. I'll then switch over to Hisham, and he'll discuss how to efficiently manage your infrastructure and applications with intelligent operations, and also showcase he'll also showcase some of the cool capabilities with a demo. Finally, I'll wrap up with some customer success stories and also some next steps. Okay, so many of you may experience an IT environment that looks something similar to this chart here, where business expectations are growing faster than the ability of IT to deliver. Today, with more users, more endpoints, and more data than ever before, there's a widening gap between business expectations and the ability of IT to deliver. Traditional ways of managing IT simply are not feasible anymore. We know that innovation is the key to enabling us to deliver at a faster pace. And we know that freeing resources and shifting them from maintenance to innovative projects is the only way that we get there. We need game-changing technology to bridge this gap and enable IT to deliver at the speed of business. VMware's One Cloud Any Application architecture, powered by the software-defined data center, can be this game-changing technology. And at the foundation of all this is VMware vSphere with Operations Management. So what exactly is vSphere with Operations Management? Simply stated, vSphere with Operations Management is a bundle that combines vSphere, which is the world's leading virtualization platform, with management tools that give you the ability to manage your data center with intelligent operations. So let's talk a bit about what IT needs to do to meet the demands of today's business. To stay ahead of the competition and to take advantage of business opportunities, infrastructure needs to be able to support modern applications that include cloud, mobile, social, and big data applications. IT also needs to be able to minimize downtime so that businesses aren't impacted. And finally, IT needs to be able to maximize performance for existing applications so that the business can be more productive. Improving performance and reducing downtime remains a complex and expensive challenge, and IT teams need to be able to proactively address these issues rather than see firsthand results from end users. Now, to accomplish this, IT needs meaningful insights, all in one place across the whole stack and leveraging all types of monitoring data so that IT teams can take proactive action. IT also needs better visibility into dependencies of applications and infrastructure components to avoid unwanted side effects of changes and extended troubleshooting. And should problems arise, IT needs to be able to rapidly identify, diagnose, and remediate those problems. And where possible, automation should step in and take care of the remediation, sometimes before the administrator even is aware of the problem. Finally, to be proactive, you need the tools to forecast and plan for the future so that potential issues never really become big issues. So IT needs to become a strategic partner to the business. They need to be able to make the business efficient and agile, but then they don't want to get away from the other teams doing their jobs. So rather than empowering, they need to empower them to do their jobs faster and more cost effectively. If they're able to do this, and if they're able to do their jobs more efficiently, then that basically frees up time for them to innovate instead of maintain status quo. Now let's talk about how vSphere with Operations Management can be that tool to bridge this gap, enable IT to deliver for their business. vSphere really is the platform for any application. This includes both scale-up applications such as traditional business-critical applications like Oracle and SAP that may be very resource-intensive, as well as scale-out applications such as cloud, mobile, social, and big data applications that might be more distributed in nature. Across the board, we have increased scale to meet even the most demanding applications. We increased scale 2x, 3x, and even sometimes 4x. Well, that is, except for one exception, and that's the CPUs per host, but that's only because we couldn't find a server that had more than 480 CPUs. If you guys know of one, please let us know. Now, Distributed Resource Scheduler, or DRS as it's better known, is a feature in vSphere that is all about making your VMs happy so that they can perform at their peak. DRS dynamically allocates and balances virtual machines to guarantee optimal access to resources. This can be helpful capacity. This can be a helpful capability as demand for applications grow, especially in dynamic environments. VMs are essentially moved from servers where they have enough resources to perform well. In addition to load balancing your VMs with DRS, you can also make them run better by prioritizing the storage and network resources that they get. So storage and I/O network controls dynamically allocates the available I/O resources to VMs according to their rules that you set, and this ultimately improves the service levels. For your business-critical applications such as Oracle or Exchange, you would want these applications to have top priority to access the storage and resources. You never want these applications to be starved for resources or to go down. On the other hand, for less critical workloads like non-production workloads such as your print servers, these are applications that are okay if they have lower priority and if they go down temporarily. The worst thing that will happen is someone complains at the print server that their document isn't coming out fast enough. So in vSphere 6, we also targeted specific types of workloads. Now, desktop virtualization is one of these workloads. If you ever use desktop virtualization, you know that the experience can be less than optimal. The experience can sometimes be clunky, and it may even take a while for screens to refresh and catch up to the action of the keyboard if the application is really graphic intensive. With NVIDIA Grid vGPU, you'll experience superior 2D and 3D graphics in your virtual environment. Really, the difference is like night and day. On the one hand, with NVIDIA Grid vGPU, you have on the one hand, without NVIDIA Grid vGPU, you have sluggish screens. But on the other hand, with NVIDIA Grid vGPU, you have a very highly responsive graphical environment. With scale applications, we know that rapid deployment of nodes are very important. And with Instant Clone, a foundation is put in place to allow rapid cloning and provisioning of virtual machines. With Instant Clone, users can deploy thousands of virtual machines in a matter of minutes versus what would normally take hours today. This has very useful applications in use cases such as big data and, again, desktop virtualization as well. So now let's talk about availability a little bit and how to minimize downtime. So VMware understands that maintaining uptime for applications is just as important as making them run well. vSphere vMotion enables live migration of running virtual machines from one physical server to another with zero downtime, continuous service, and complete transaction integrity. vMotion is by far one of our most popular features. When we first introduced the feature, our customers were blown away because they never thought that such awesomeness was possible. The idea of being able to move a workload without any downtime was just unheard of when we first introduced the feature. With storage vMotion, this is similar to vMotion, but instead it works on the VMDK file. You're able to perform live migration of virtual machine disk files within and across storage arrays with vSphere storage vMotion. You're able to relocate virtual machine disk files while maintaining continuous service availability and complete transaction integrity. So vMotion and storage vMotion, does similar things. One works on the VM level and one works on the disk level or the VMDK level. But the idea is that you're able to move your VMs without any downtime, which is huge when you are planning a maintenance or something. You don't have to shut down your workloads, and you can continue working while the migration is happening. And the innovation for vMotion doesn't stop. In vSphere 6, we introduced what's called long-distance vMotion. And VMware continues the innovation of migrating live workloads by offering this long-distance vMotion that spans the boundaries of virtual switches and vCenter servers. Furthermore, it's now possible to perform a long-distance vMotion of distances up to 150 milliseconds round-trip time. Now, to put this into perspective, with long-distance vMotion, you're now able to do a vMotion between data centers that are physically located in New York and London. So this is totally game-changing in terms of how data centers are laid out and how close they need to be with each other. You're now able to have data centers that are on different continents and still satisfy disaster avoidance requirements. Now, equally as important as planned downtime is unplanned downtime. vMotion is great when you know that you have to shut down your servers or perform maintenance. But what about when you have hardware failure? That's exactly what HA and fault tolerance is for. Now, HA, or high availability, is all about providing easy-to-use, cost-effective high availability for applications running in a virtual machine. In the event of a physical server failure, the virtual machines that are affected are automatically restarted on other production servers that have spare capacity. Or in the case of operating system failure, vSphere HA is able to restart on the affected. So in the case of a operating system failure, vSphere HA is able to restart the affected virtual machine on the same physical server. So vSphere HA is basically allows your IT organization to first minimize downtime for server and operating system failures, and then you're able to increase protection across your infrastructure. Now, related to HA is vSphere fault tolerance, and this basically provides continuous availability for applications in the event of server failures by creating a live shadow instance of virtual machines that is in virtual lockstep with the primary instance. And by allowing instantaneous failover between two instances in the event of a hardware failure, fault tolerance is able to eliminate even the smallest chance of data loss or disruption. So with fault tolerance, you're able to automatically trigger seamless stateful failover when the protected virtual machine fails to respond for zero downtime or zero data loss. And you're also able to automatically trigger the creation of a secondary virtual machine after failover to ensure that continuous protection of the application is happening. So in addition to scale, performance, and availability, we also know that customers want a simpler way to manage their virtual data center environment. So with vSphere 6, we're able to simplify the management of your virtual data center content and infrastructure through a combination of many new and innovative features. The first feature I want to talk about is all about rapid deployment and provisioning of your VMs. So vSphere, with the operation management, automates data center tasks to improve efficiency and utilization. But host profiles and auto deploy works together to do just this. Host profile lets you create a profile once and then use it to configure multiple vSphere hosts. And then auto deploy basically takes that host profile and then rapidly deploys and patches vSphere hosts in minutes with it. So basically, you're able to scale out much quicker using a combination of vSphere host profile and auto deploy. With vSphere Distributed Switch, you're able to centrally configure and manage all your virtual switches across your entire infrastructure. This basically saves you a ton of time and frustration. You're able to do so individually for each. So if you're going to do this individually for each switch, it can take upwards of 15 to 20 minutes. But with the distributed switch, you're able to configure once and push the setting out to all your other virtual switches. And by doing this, you basically save a ton of time and a ton of frustration that you would get if you didn't have it. And then Content Library provides a simple and effective management for your content, including VM templates, ISO images, and scripts. With the vSphere Content Library, you're able to now store and manage content from a central location. Furthermore, once the content is stored, it's easily shared through a publish and subscribe model, even for VMs that span the boundaries of vCenter servers. Finally, the stored content can be quickly deployed from the content library directly onto a host or cluster for your usage. This means that it's now possible for a single administrator to manage the content for many users. Users can now subscribe to the content, access it when it's ready, and deploy it from the content library directly into their environment. it basically allows you to share much more easily, and it saves you efficiency in terms of how you utilize your. It saves you a lot of time in terms of where you utilize your resources. So with this said, I'm going to now hand it over to Hisham to talk about how to efficiently manage your infrastructure with intelligent operations.
Hey, thanks very much, Martin. So this is Hisham Murad with Technical Marketing. So thank you very much, everybody, for attending. So I'm going to walk through now and talk about how we can efficiently manage the infrastructure and our applications with intelligent operations. So I'm going to give a few highlights here. I'm going to keep the slides fairly light because I want to spend a little bit more time in the demonstration portion of this recording. So let's talk about first unified dashboard. So one of the great things about our operations management platform is we give you that unified dashboard where you can really get a feel for what are the immediate issues, where do I have some risk in my environment, anything related to capacity, but also where do I have areas of improvement within my environment. So let's very quickly show what that unified dashboard looks like. So here is the initial UI that when you log into vRealize operations, you're going to see this initial recommendations page, and this is where we surface all the information about your environment into this dashboard here. So again, you can see that it has three main columns. The first column is the health column. This is where, again, we show you some of those immediate critical issues that are taking place where you really need to focus on troubleshooting. And you can see right now I have a few issues that are sort of in that red, a few issues in that orange. Those are areas where I really want to start investigating. And you can see the associated alerts with those issues below that initial graph in that first column. Now if we transition to the second column, this is the risk column. This is where we have, again, issues that are related to risk, things like vSphere, compliance. How well do I meet my vSphere compliance guidelines? Do I have any issues related to chronic issues, so things that relate to CPU or memory or storage, but that are chronic? And what I mean by chronic is that typically means that they're ongoing, which means that they're potentially capacity related. And so these are areas where we want to go in and address as well. And then lastly, we have the column around efficiency. And this is where we have opportunities to improve the environment. And so for example, if you have a large number of snapshots, or if you have a lot of idle VMs, where you can go in and potentially power them up. So areas where you can reclaim capacity, improve and optimize the environment, those are the type of things that we will surface within the efficiency column. So a great unified dashboard here and UI which allows you to drill in as deep as you really need to. So let's move on to the next area, if you will. So the next area is log analytics. So with vRealize Log Insight, we give you that 360 view and allow you to do troubleshooting by leveraging those logs. So one of the things that I find a lot of clients today, they're not really leveraging the logs within their environment. So physical devices, operating systems, applications, they all generate logs. But there's a large number of logs. There's a very large quantity of logs. And it's very difficult to go through them. So you need some sort of log analytics solution that can really help you make sense of those logs that we have within the environment. Now, having said that, let's take a quick look at here. So I typically say, logs for the last mile to root cause analysis. So we'll talk a little bit more about the difference between the data in VROps and in Log Insight. But when you look at this here, what this is doing is, this is the UI for vRealize Log Insight, and we're actually consuming all the logs and all the Windows events and anything coming from applications, from physical devices, from operating systems, and we surface that information here through these dashboards. And here you can see that I have some, dashboard 1, 2, and 3 that are customized by me, but we provide you out of the box a number of different content packs with pre-built dashboards and queries. So it makes it very easy for you to consume those logs and really make sense of them and analyze those logs. So we handle the log analytics here for you. Now, next, what I've just popped up, the second graph is, now once I've looked at these logs, I want to dig down deeper. I want to dig deeper into these logs and be able to do some, custom queries. So I have the ability to go in and dig deeper into the logs and do custom queries and modify different chart types to visualize that data in many different ways and really kind of determine what is that root cause analysis here within the environment. So again, this is taking all those logs which are really hard to understand, hard to consume, and making them in a consumable, in a very easy way, leveraging this very simple UI to understand this data. So here, for example, in the bottom portion of this second graph that just popped up, this is where you go in just to look for things like SCSI errors, NFS errors, etc., etc. But these are all here. But the great thing is that in reality, you don't have to actually go and search for this, because we provide you the content packs and the dashboards, which were in that left graph, where you can actually see all this without you having to go in and dig for it. And that's the beauty of log analytics, where we analyze that data, analyze those logs for you, so you don't have to go and do all the digging. Now, when it comes to managing your environment in an intelligent way, leveraging our operations insight, you're leveraging vRealize Operations and vRealize Log Insight together. So the first unified dashboard I showed you, that was vRealize Operations. That allows you to basically understand the structured data within your environment. So the left portion of this graph here is, you have information coming in the form of metrics and events, and we actually capture that structured data and we analyze that for you with vRealize Operations. And then on the right-hand side, we have all the logs and the Windows events and other type of events that are coming through, and that information is coming through in the form of unstructured data. So we have structured data on the one hand, unstructured data on the other hand, and leveraging vRealize Suite, we can actually analyze that information through vRealize Operations and through vRealize Log Insight. Now, the great thing about these two solutions also is that they're integrated. So we have launch in context between these two. We have alert integration between these two, and I'll show you that here in the demonstration shortly, where I can surface an alert in Log Insight and see that come through to vRealize Operations, and it allows me to troubleshoot both from a structured data perspective as well as a unstructured data perspective as well. Okay, so let's move on to the next slide. Excuse me. So let's talk about actionable alerts and guided remediation. So this is an important area. So when I talked about that unified dashboard there, and when we talked about the three columns of health, risk, and efficiency, you saw on the bottom portion of that screen, you saw a number of different alerts. Now, alerts are great, but what makes them more important is being able to take action based on those alerts and have some sort of guided remediation as a result of those alerts. So here you can see I actually selected one of those alerts that I saw in that unified dashboard. I went to the details of the alert. I can see what the alert title is. I can get some information around it. I can see the recommendations, but also in that recommendation here, you can see that I have an action. So it says here, and take action, set the memory, for this virtual machine. So I can actually select that and actually resolve the issues for this machine. So this machine has some, high memory usage causing stress. So again, this has been ongoing, which means that, I've been high for memory for a long time, which essentially, if it's chronic, it typically means maybe I'm undersized. I need more memory. So the great thing about the recommendation here is saying, add more memory. This has been ongoing. So let's resize this virtual machine. So again, we provide you that action right in the alert, so you can actually take action right from here. Now, the beautiful thing also about our action framework in vRealize Operations is you can automate this. So instead of me actually having to come here, select this alert, and then click on the Set Memory for VM button, I can actually automate this. Now, I typically tell customers that, okay, wait a little bit, get familiar with these alerts, get familiar with these actions that we have as part of these alerts, so these actionable alerts, and then once you're comfortable with them and you've set up your environment just the way you want it to, you can actually now go and say, I want to automate this alert. So now any alert that comes back with this type of alert and recommendation and an action associated with it can take place automatically. And the beautiful thing is that we will make sure that we audit it and record it for you. So you don't have to worry about, not knowing that this took place, because we have a complete audit trail of that. You can go in to the administration page and basically look at that complete audit trail and generate a report around that if you choose to. So actionable alerts are an important area as well, and we'll show you that in the demonstration here very shortly. The other thing I want to talk about is intelligent workload placement. So, this is another area where, we see customers where, they have infrastructure within their environment, and in some cases, some clusters potentially are, underutilized, some clusters are overutilized. Now, we have something called DRS, Distributed Resource Scheduler, which does a great job balancing contentious VMs within a cluster. But you want to be able to leverage some of that capacity across clusters. So what happens sometimes is, again, as I mentioned, some clusters are going to be utilized, some are going to be overutilized. You want to achieve better balance and better consumption of the overall capacity resources within your environment. So DRS can do a lot of great work for you within that cluster. But what happens when you have a cluster that is in fact consumed all its resources, or highly utilized for all its capacity resources? DRS is not going to be able to do any more balancing there. But if you did have another cluster that potentially has some resources, then we can essentially leverage workload placement and actually move VMs from one cluster to another to better take advantage of the resources. So let's make those VMs and those applications happy by leveraging both Distributed Resource Scheduler and the vRealize Operations workload Intelligent Workload Placement feature, or WLP, to better balance those workloads across clusters and better leverage the capacity within our environment. And this is what we're talking about here, is this better together story by leveraging both DRS and vRealize Operations workload balance. And this is a demonstration I will actually start with here very shortly, because I'll kick off the application and then there's going to be some migration of workloads, and I want to come back and show you the result of that. So the idea here again is we want to be able to rebalance these type of containers. Now, what are the containers that we can rebalance? So when we talk about vRealize Operations, you can actually rebalance two different types of containers. One is a container called a custom data center, which is a new construct that was introduced in vRealize Operations 6.1 and higher. And the other type of container that we can rebalance is the data center, which we're all used to and very familiar with in our virtual infrastructure. So when you go to rebalance a container, so there's an action called rebalance container action. Again, I will show you that here momentarily. And that allows you to essentially balance workloads between clusters. So in my data center, I could have one or more cluster, or I can create a custom data center that I can selectively include clusters in that custom data center. And I say I want to be able to balance workload between these. So my input here is a data center or a custom data center. My output is going to be a rebalance plan. So it's going to come back and say, this is a plan. These are the workloads that I recommend you move from this cluster to this cluster, and we can achieve better balancing across those clusters. Now, so there's a different logic that it will leverage. Where will it best fit? The current workloads, it's going to look at the VMs. It's going to look at the provider objects and determine, and come back with a plan in terms of where best should I move these VMs. Now, one thing I want to touch on here is that workload placement in VROps is not oblivious of DRS. As a matter of fact, they work together. So DRS does the workload placement and workload balancing within the clusters, but vRealize operations workload placement talks to DRS and leverages DRS and says, and so we talk to the DRS APIs, and then so we say we need to move this VM from cluster 1 to cluster 2, and then we hand it off to DRS and we tell DRS, hey, we need to put this in cluster 2. Now you determine where we need to put that virtual machine in that cluster. So DRS then determines where we're going to place this. Now, one thing you need to note here is that we do need to have DRS in fully automated mode so that this will all work. And again, when you execute the action, you're going to execute it on a custom data center, or we typically call it CDC, or a data center object. And again, I'll give you more details on that here as we walk through. Now, when you click on the rebalance action, it's going to come back with this rebalance plan. And so the rebalance plan, as you can see here in the graphic on the left-hand side, is showing you I need to move these 3 VMs from my production 1 cluster to my production 2 cluster. There's one going from production 2 to production 1. So I'm kind of moving VMs, appropriately based on, their different constraints. Some have CPU constraints, some memory constraints, some storage constraints, etc. And we'll basically intelligently say, if you move these here across these clusters, we can achieve better balancing as a result. Now, one thing I also want to say is that, as I mentioned on the previous slide, we're not doing this, workload placement in VROps is not oblivious of DRS. So we work in conjunction with DRS. So what that means is we will respect any DRS affinity and anti-affinity rules. So we're not going to be moving, VMs willy-nilly, if you will. We're going to make sure we do this very intelligently so we're not impacting and violating any of your affinity, anti-affinity rules within your environment. Okay, so let's go through a few examples, and then we're going to jump into the demonstration here very shortly. So let's first take a look at what the workload utilization dashboard widget looks like. So you can see here there's sort of a graph on the screen, and the leftmost portion of this is sort of that underutilized zone. The middle portion, sort of that lighter green, is the optimal zone, and the closer you get to that green line is sort of that optimal area. And then as you start to move away from that green dotted line there, further to the deep red area, that's when you're starting to get into the overutilized area. And you can see here that you can see clusters and hosts and workloads that are kind of ranging within those different zones. But if you look at the cluster specifically, you can see that I have 2 and underutilized. I have 1, fairly close and in the optimal zone, but fairly close to the most optimal. And then you have a cluster in the right-hand side, which is overutilized. Well, wouldn't it be nice to leverage some of that capacity that's available in my underutilized clusters, and those clusters that are in my underutilized zones, because you can see there's a number of hosts there that belong to those clusters that are in that underutilized zone, and want to bring those together. So this would be a great way, or a great candidate here in this environment would be to do a workload, a balance container action to better balance these different clusters. Now here's another example. We call this one sort of this scenario a Robin Hood scenario, where you have a cluster that is very underutilized, and you have a number of clusters that are very overutilized. And we can take from the the rich and give to the poor, if you will, here, and basically we can better balance workloads and bring those clusters closer together into the optimal zone and provide better balancing here. So that's another example, right, of what you may potentially see. Now here's another environment where you have a number of different clusters. They're all in the overutilized zone. But here I'd like to just preface this. You can see here I have two clusters where I'm showing that are memory constrained, two clusters that are CPU constrained. Well, I could potentially achieve just better balance if I better balance those memory constrained workloads and the CPU constrained workloads, and and balance those across clusters. Now, we can get a better balancing here, but let's say everything here was memory constrained, or everything here was CPU constrained, and everything is in the red. And that would typically mean, if I'm in the red for long periods of time, that would typically mean that essentially I have some, capacity constraints, which means potentially my clusters are capacity constrained, which means I really need to potentially jump into now doing some capacity modeling and looking at, provisioning additional capacity as well. But in the example on the screen here, where you have some memory constrained, some CPU constrained, you can certainly balance those workloads better and achieve better balance and bring some of those clusters, further down into the lighter red, closer to the green, if you will, and achieve better balance. So that is a great option there for you as well. Now lastly, what you are trying to achieve, and this is obviously, the nirvana here, but it may or may not be achievable to this specific perfect balance here, right? So in any given customer, where you have workloads and things are happening at varying times and whatnot, you may not be able to achieve this level of balance, right? Everything is in that optimal zone. But as long as you're within that green and low level of, pink or the, the light red there, if you will, that's really where you want to be to take, best advantage of the existing capacity resources and CPU and memory and storage within your environment, right? So this here is highly optimal. I mean, you may be able to get some environments like this, but in reality, you want to be, in that green, light red area. That's going to be the optimal zone. Now, let's jump through here to a demonstration. But just before I jump into the demonstration, I just want to talk about the different things that I would like to kind of walk through a demonstration with you. So first of all, I want to talk about workload placement. So the last topic I just discussed, I want to demo it first, because I want to demo taking the rebalance action first, and then after that last demo, we'll come back and show you that screen and show you how that looks at the end as a result of a workload balance action. So we'll talk about workload placement. We'll execute a rebalance container action. The next thing I want to show you very quickly also is actionable alerts. So being able to do things like, taking an alert and being able to execute an action in that guided remediation. So I showed you a screenshot of that, but what I really want to do is run through one, maybe two examples, depending on time here, and show you how we can execute on those actionable alerts and that guided remediation. And lastly, what I want to do is show you in my environments where I am actually quite constrained for capacity, show you how we can go in, visualize capacity, but then also be able to do capacity planning and start to see how I can change my environment by executing on some, what-if scenarios, if we will, within that. So I'm going to go ahead now and share my screen, and we'll walk through the demonstration. All right, so I'm hoping at this point that you can see my screen. And so what we're looking at here is visualize operations, and I'm looking at the workload utilization dashboard. So this is a dashboard that's available in Visualize Operations Manager. It's out of the box, and so if you go and install Visualize Operations 6.2, you will have this dashboard. And so let me just do a quick refresh because the screen here has been sitting. I just want to make sure that it has not timed out on me for login, and gives it a quick refresh. So now let's take a look. So my environment here is very small. I only have essentially 2 clusters here. So this is my production 2 cluster, which is sitting at a moderate workload here of 66%. So it's in that optimal zone, if you will, here. But then I have a production 1 cluster, which is in my overutilized zone here. And so you can see it's actually, on the far right, it says here it's overutilized. I can click on it, and when I click on it, you can see it's going to update these 2 widgets down here on the bottom. And I can see in this specific cluster, I'm actually constrained for CPU. So some of the applications that I'm running are actually CPU heavy. And so you can see here, and I can take a look, back in time, if you will, and see what my workload trend has been like. And if I want to go, further back in time, I can even go back, in time by selecting a specific, time range, if you will, and look at that. But you can see when I selected that cluster, it actually just made that other cluster disappear, and now it's showing me the different hosts within this cluster. And you can see 95 with this one here is 96, and I have one here at 102. So these are, fairly utilized hosts here, right? And, I really want to bring their level of utilization down. So if I uncheck that cluster, now you can see within this cluster show back up again. I'm going to click on that cluster, and within this cluster, I have 2 hosts, and you can see these 2 hosts are in fact, more memory constrained, or this cluster, if you will, is more memory constrained versus CPU constrained, right? So, having said that, what I'd like to do is those hosts were more CPU constrained. The hosts here are more memory constrained. If I uncheck that, I can certainly balance these 2 clusters better here. Now, in order for me to balance these, let's take a look at the overall data center object here. So here's my overall data center. I'm at like over 70 for CPU, in the mid 60s here for memory. But again, looking at the clusters, one is overutilized, and I can achieve better balance between these 2 clusters and between all these different hosts here. So what I'm going to do is this is the virtual data center. As I mentioned earlier, when I execute a rebalance container action, that actually takes place on either a data center object or a custom data center object, which I have some custom data center objects, but none that have these 2 clusters in it. So I'm going to do the rebalance here based on this data center object. So I'm going to select the details of this. And now what it'll do is it'll take me to the analysis tab for that specific cluster object. And I can see here, my workload for CPU, my memory. I can see that, in fact, I do have some, VMs here that are causing, CPU contention, memory contention. This is my SAP application, right? So very heavy workloads here. But really, what I want to do is show you this rebalance container action. So I'm going to select this rebalance container action, and it goes out and says, okay, based on what's going on here, let's go ahead and move these VMs from my production cluster 1 to production cluster 2. And the reason why is because we have some imbalance on CPU demand here. So let's go ahead and begin that action. So I'm just going to say begin action. Now, that action is taking place in the background. It tells me I can go look at it in the recent tasks where everything is audited, and it gives me a specific task ID. So I'm just going to click on OK here. I'm just going to go back to that screen I was looking at previously, and so it still hasn't changed here, right, because I just executed this. So what we're going to do is we're going to go and take a look at those other demos that I want to show you, and then at the end I'm going to come back, and what we'll do is we'll look at this screen again, and we'll start to see how the rebalance is taking place. So I'm going to keep that tab right there, and we're going to come back to that. Now, let me show you just an example of this unified dashboard. So remember we talked about the unified dashboard. This is when you log into vRealize Operations. This is essentially here what you are going to see. Okay, and so what you're going to see here is all the alerts within your environment surfacing in one place, right, kind of giving you that short list of alerts where you need to go and troubleshoot. Okay, so first of all, I want to take a look at an example of a actionable alert with some guided remediation. So virtual machine has continuous high memory usage causing stress. Well, we saw certainly in the one cluster we had high CPU, and the other cluster, we had high memory. So let's take a quick look at that. So if I select that, you can see here that in fact I have some VMs that are experiencing this alert has triggered on. Well, let's take this top one here and take a look at this. So we'll go to the details of that SAP server object, and now you can see that here my stress level has been 75%, not my workload level, not my memory level, but my actual stress level. What this means is I'm spending 75% of my time above a threshold of 70% workload. That's what the stress, means. Our default stress threshold is 70%, and so here the stress, score is 75%. So 75% of my time is above 70% workload. And so now you can see it's telling me here, it gives me a detailed description of this alert. It gives me a recommendation here, add more memory for this virtual machine, and it says set the memory for this virtual machine. So I can actually select that action, and here it's saying, okay, well, I'm currently at 2 gig of memory, and I'm recommending, based on the requirements, based on the history of this virtual machine, I am recommending you here go to 4,552 megabytes. Well, you know what? I'm a little conservative here, so maybe what I want to do is not go to that. Let me just go to 3072, for example, and that's what I want to change it to. I do want to power off this VM to make that hardware change, and the reason why is because the OS on this machine does not support hot add. If I did support hot add, I do not have to select this power off allowed. If this is a critical virtual machine for me, I can snapshot it before I actually take this change. So I can basically, make sure I grab a snapshot of it, and I can select a snapshot here too, but I'm not going to do a snapshot at the moment. But I'm just going to say, sure, go ahead, begin this action. So what's going to happen is it's going to go ahead and actually take action on that virtual machine. It's going to basically power it down, increase its memory, bring it back up, and then so it'll have more memory resources to handle the memory requirements that have been requested of that SAP virtual machine. And again, I can go and track it using this ID in the recent tasks if I choose to. So that was one alert I wanted to show you. Now, another alert I want to show you here is around the integration with Log Insight. So a couple of things I'd like to show here is, first of all, let me go into notification events. So alerts that are coming in from vRealize Operations from Log Insight, vRealize Log Insight typically come in as notification events, and you'll see them here, so you can go in and look at these notification events. Here's one example, and so I select that example, and you can see here it says Log Insight, high latency on that ESX host. So it's telling me I have high latency. So this high latency is being actually discovered from the vSphere logs on this virtual machine. So now what this allows me to do is I can go in here, for example, on this ESX host, and now determine, okay, from a VROPS perspective, from a structured data perspective, what are some of the issues that I'm seeing, and I can go ahead and troubleshoot here. But then also I already know that I have some alerts here that are coming from Log Insight. And the beautiful thing here is I can right from here say search for the logs in vRealize Log Insight, and it will automatically connect me to Log Insight and allow me to go look at the details in Log Insight for that specific host. So I can go in and do further troubleshooting in Log Insight. Now, in Log Insight, what am I troubleshooting? What am I looking at? I'm looking at the unstructured data in the form of logs, event messages, again, coming from anywhere in the environment, and I can troubleshoot. And that's that 360-degree visibility that I mentioned when I was, presenting in the slides, where we can see all this information and do better troubleshooting. And now here I can go in and start to look at these, high latency times within the environment. Oh, and by the way, to make this simple for you, if you actually simply go to dashboards, instead of me having to go in and do queries and whatnot in here, if I just simply go to the dashboards and I go to the vSphere dashboards, so if I go, as you know, in Log Insight here, we have a number of different content packs that you can download. But if I go to the VMware vSphere dashboard and I specifically go to SCSI latency and errors, if I go ahead and look at that, I'm going to actually find that I already have SCSI alerts by device and by host name, and I can get more information. And this is just in the 5 minutes of data. But if I even go back and say, let's take a look at it from a 1 hour perspective or even deeper, right? I'm likely going to get more data here and potentially see more times of latency. So you can see now I can track my latency. So now I had that visibility in VROPS, I have that visibility in here in Log Insight, and that gives me that complete 360-degree view. The last thing I just wanted to point out here is, if I'm somebody that spends more of my time here in Log Insight, and I'm looking at these type of events and seeing these type of events, well, also right from here, I can open analysis in vRealize Operations Manager and do essentially that launch in context back right from Log Insight as well. So it's certainly a beautiful thing being able to integrate these two UIs and do launch in context from them, again, to get that full visibility. So now let me jump back here to vRealize Operations. I want to jump into the next demo so we can start to, just for the sake of time, what I want to do is I want to go into that cluster. So if you recall, when we were looking at cluster production 1, this was the one that was heavily utilized, right? We saw that when we were looking at the rebalanced container dashboard there. And we'll come back to that dashboard in just a moment. But what I want to do is I went specifically to that object, and I want to go to Analysis tab, and I really want to focus in on capacity. So I want to show you some of the things that we can do from a capacity perspective. So let's go in here. So the first tab was telling me from a workload perspective, there's nothing broken, right? Everything is working fine. It's just that from a capacity perspective, I'm really overutilized from a capacity perspective. So now I can look here at capacity, I can drill down, and I can see, first of all, that I'm most constrained for disk space allocation, I'm constrained for memory consumed, and I'm constrained for CPU demand. And then it shows you the levels and my peak values. So 124%, 125% roughly peak value for CPU, 105% for memory consumed, 277% for disk space. So I'm highly over-provisioned here, on disk. And it's telling me that essentially based on that, my capacity remaining is, very low. So I can see that, and I can go in and dig down deeper into here. But really what I wanted to show you is being able to do capacity modeling. So I want to jump over to the project side tab here. And so what I've done, just to save time and not have to type in front of you, but I've created these 3 different scenarios. So when you look at this screen, it shows you the context of the object that you're on, in this case a cluster. and showing you that it's most constrained for memory. But we also knew it was constrained for disk space allocation. It was also for CPU demand as well, right? So we knew that. So you can switch between them and look at them individually. Or if you say most constrained, it'll just kind of give you, the top constrained resource. And in this case, it's memory. Now, I've created a project here. So this first project is, okay, well, I've been going through this for a long time, and I'm going through this for a longer period of time. I want to be able to address this. So in this, I'm just going to show one of these. But in this specific scenario here, what I did is I've actually, in this project, I've created 3 different scenarios. I'm adding physical capacity. In the first phase, on March 15th here, I'm adding 1 host. And then on March 22nd, I'm adding 3 more hosts. And then on March 29th, I'm adding 8 more hosts. And based on this, it's showing me that as I add 1 here, as I add the initial host, I get rid of some of the capacity. And then I add 3 more hosts, and I get more, add the additional capacity. And then I add the additional 8 hosts, and I actually really have a lot more capacity to take me forward. And that's great, so I can visualize that. But typically when you're dealing with customers, they need to add capacity, but they're often adding workloads, they're adding demand. So here I'm simulating not just adding capacity, but also adding workloads. So here, for example, this West Coast application that I need to add. And in this application, I am adding 2 additional virtual machines. Right, so just wanted to show you that. So that's going to increase my demand. Now this other one here, this is my East Coast application. And this one here, I'm going to be adding 3 more virtual machines. Again, increasing my demand. So this red here is my capacity shortfall. And I'm actually making it worse by adding virtual machines. But now, because I'm doing this planning, and first of all, I want to say, let me add these hosts that I want to add at a staged phases. Phase 1, Phase 2, Phase 3. I've gotten myself out of the capacity contention here for memory. And if I go look for CPU as well, you'll see that. But now I know I need to update on March 24th. I need to essentially add this application in the West Coast. Now that's going to add demand. And so you can see here, my demand went back up. So 2.1 represents here, my demand 2.1 went up. But I still have enough capacity, right? But up to 1.2, where I added the 1 host, the 3 hosts, I've essentially eaten up that capacity right here. But then, thankfully, in 1.3, I'm adding 6 more hosts, which means I have more room. But now, what if I add the East Coast application? Do I still have enough capacity? And so I'm adding my East Coast application, that's my 3.1 here. And so you can see here, it's project 3. And so 3.1 is the first scenario, the only scenario in there. And I'm adding 3 more virtual machines, which is adding more demand, but I'm never going up above my total capacity. So I'm never going back in the red range. That red range was my shortfall, as you can see here, capacity shortfall, showing you that in the legend. So by doing this, I can simulate that adding these hosts and adding these 2 new applications, which require more capacity and more demand, based on this, I've actually bought myself time for the future, being able to simulate getting out of my existing capacity contention and making sure I have enough capacity to handle these new projects coming online as well. So very, very powerful thing to be able to do capacity planning in vRealize operations. Now let's jump back to this screen. This is what that screen looked like before from the workload placement. Now if I do a refresh on this, now what you're going to see is my data center was around here, I believe, something like that, and now it's moved down. And my clusters have better balancing because you remember, some VMs had memory contention, some had CPU contention, And now if you look at this, right, my clusters are better balanced. Now what will happen is DRS, though, will continue to look at the workloads within these clusters and try to do more balancing as well. So even with more time, you're going to get better balancing between these clusters and these workloads. So you can see here we're getting close to the green. We don't have everything in the green, but we're getting there, right? And so my environment, 70, 80, way better than what I was before, where I had 102, everything, a couple of others were in the 90s. So truly better balance and better leveraging my environment overall. And this is the power of workload placement in real-time operations in addition to distributed resource scheduler and working together to give you that better performance. So now what I'm going to do is stop sharing, and I'm going to hand it back over to Martin, who will take us through the rest of the slides and the rest of the demonstration.
Okay. Now, thanks, Hisham, for the demo. That was very insightful. So customers are always asking, how soon do they get a return on investment in the purchase of vSphere with Operation Management? And I like to tell them very, very fast. As you can see here, customers are reporting on average a return on investment of 2.4 times return on investment. They're able to reduce their IT costs by 53%. They're able to gain 30% more visibility on average over their infrastructure, and they're able to decrease their downtime by up to 54%. Now, these are all averages. Some companies experience more, some companies experience less, but regardless, these are huge numbers. And depending on the company, this could mean literally millions and millions of dollars in savings and productivity. So let's dive into a couple of specific customer examples. Okay, so Cornerstone Lending was able to save 70% in hardware costs, which is already significant. Their director of server operations, Ricky Caldwell, says that for the first time ever, we're able to capacity plan and look ahead and forecast what we're going to need for the next 1, 3, or even 5 years. They liked this so much that they originally had Hyper-V in their environment, and they actually displaced Hyper-V for vSphere with Operation Management. So that's how much value they found in vSphere with Operations Management. Millennium Pharmaceutical was able to increase their VM density by 20%. And they were also able to increase the efficiency by 25%. And then finally, they were able to, because they were able to work so much faster and work so much more efficiently, they were able to decrease their operational costs by 20%. And then finally, the Waddington Group, they were able to, again, spend 80% less time in integrating their back-end systems. They were able to achieve 52% in increasing consolidation ratio. So huge numbers across the board. All these companies found huge value in what they were able to do with vSphere with Operation Management, ultimately saving them millions of dollars. Okay, so with that said, what are the next steps? If you found value in vSphere with Operation Management and you want to learn some more, we encourage you to continue looking at our solution. We have a free ebook, Virtualization 2.0 for Dummy. Just go to that URL on the screen and download the free ebook. If you're interested in evaluating vSphere with Operation Management, feel free to go to the second URL and download our free 60-day evaluation. You're able to get the highest edition of vSphere with Operation Management, try all the cool new features. And then finally, we have the hands-on lab where, if you don't want to install vSOM with operation management in your environment and you want to try out specific features, we have labs online that enable you to try out features without having to deploy the entire environment in your infrastructure. So we encourage you to definitely check that out. And with that, we thank you, and we will open it up now for questions and answers.